Okay, so we're still optimizing area and perimeter. Okay, so we're still working with 2D shapes, but we're gonna start working with optimization with restriction. Okay, the easy stuff is optimizing without restriction. So among all rectangles with a given perimeter, a square has the maximum area. We just discovered that, we talked about that. We have the questions with that. And then among all rectangles with a given area, again, a square would give you the minimum perimeter. Guys, remember that there's always something given to you. They either give you the perimeter and then you have to maximize the area, or they either give you the area and you have to minimize the perimeter. Okay? So, as I said earlier, I'm not going to do example 1 and 2 because they're exactly similar to what we just finished. So we're going to move on to optimizing with restriction. Now, it may not be possible to form a square because of certain restriction. In restriction means, let's say if you want to build a fence, but you want to use the wall as one of your sides. So you don't want to fence that side. Okay? So you have a house, right? Now you want to build a garden. Right? So this is your house. You want to build a garden around it, right? So you want to build a garden, right? You want to fence. Do you fence the side? Do you fence the wall? Do you actually fence the wall? Do you? No. Because the wall is already blocked, right? So what you fence this, this, and this, right? So now you have a restriction. You don't need to fence that wall. No. So what you're fencing, you're only fencing 3 sides. You're not fencing 4 sides anymore. Because you don't fence the wall. It's already there.
Yeah.
Oh, yeah.
Right? You don't fence it. It's a waste of money if you do. Right? So you're only fencing 3. So when this happens, then it can't form a square. The square will not give me my optimal values. Okay? So let's look at some examples. A rectangular garden is to be fenced using the wall of a house as one side. The garden should have an area of 40 meters squared. Determine the minimum perimeter and dimensions of the garden. If the dimension must be whole meters. We're just going to do whole meters. We're not going to even bother with doing this. Okay? So, I know that my area should be 40 meters squared. Okay? What length and width would give me 40 meters squared? So let's start with, if the length is 1, what would be your width? Right? Now, if I want to do my perimeter, right? What I have here is I have this. So I have 1 plus 40 plus 1. And I'm only fencing 3 sides. Right? Do you guys understand that? Do you understand that I'm only fencing 3 sides? So that would give me 42 meters. Okay? Now, if I multiply 1 times 4, that would give me 40 meters squared. So that's my area. What if my length is 2? What would my width be? 20. Because 2 times 20 gives me 4. So I would have 2, 22. What's my perimeter?
24.
Can I divide 40 by 3? Can I divide 40 by 3?
40 by 3. No, I really have the.
That's right. Okay. How about 40 by 4? Yes, I can.
Yeah.
4 times what gives me 40?
10.
So if I have this shape, 4, 10, 4, so that would give me 18. Can I divide 40 by 5?
Yes.
5 times what gives me 40?
8.
So that gives me 18 again. Right? Can I divide 40 by 6? By 7? By 8? So if I have 8, 5, and 8, what is that? 21. Can I divide 40 by 9? No. By 10? So I would have 10 by 4 by 10. And can I divide 40 by 20? Now, if you're looking at this, what do you notice? Okay. What else?
I've always known this.
So the two middle numbers are 18. So I have two dimensions in this case that gave me 18. I have 4 by 10 or 5 by 8. And they both give me 18. Right? If I actually go deep into decimals and try to find an answer, there will be some decimal dimensions that will give me a perimeter that's less than 18. Okay? That's why you see that 18 and then 18. But there's actually a decimal number in the middle, okay, that would give me a perimeter of less than 18. Okay? But in this case, in the case of whole numbers, right, I'm going to say that if I use 5 by 8 by 5, or if I use 4 by 10 by 4, they both are going to give me the same perimeter. So I can either go with either dimension. Do you guys get that? Okay? So what I did right here is I actually did a table of value. I did trial and errors in order for me to be able to get to my formula, okay, to my solution. There is a way to do this. Let's think about what am I starting with? What is given to me?
Area.
The area. What's the area of a rectangle?
L square.
Of a rectangle.
LW.
Okay. So, in my rectangle right here, this is L and this is W. Okay? This is how I've used my picture. So I have L, W, L. Right? Now I know that my area is 40.
Look at the rules on the board. FX.
Right? That's what's given to me. Now, just let's focus with me on this because this is a little bit like it's harder than what we've done. So just pay attention to it and then you guys can copy it. So I know that my area is length times W. Now what is my perimeter?
2LW.
2L plus W. How would I write that? Now, if I write that, that would give me my regular perimeter for a full rectangle. But in this case, I don't have this.
Yes.
So what is my perimeter for this case?
2L plus W. 2L plus W.
Which which is the same as L plus W, right? So I have 2L, right, and 1 W.
You have to work it out.
Okay. Now, in this case right here, I have 1, 2, 3 unknown. In this case, I have 1, 2 unknowns, right? The L and the W. Now, if I actually isolate for one of the unknowns and I place it here, then I'll end up with 2 unknowns. So,
Here in this one.
L is going to be, so a W is going to be in terms of L. So look at this. So if I do 40 divided by L, it gives me W, right? You guys agree with that? Okay. I'm going to place, instead of W, I'm going to place 40 divided by L in here.
Almost there. So what are you supposed to do now? You want to be left with K. No, don't do that. You're almost there though. That's it.
Okay?
You know what to do.
So, according to the length that I have used, okay, I can plug in the values for L here, and I can find the W. I can find the perimeter.
You want to get left with K.
Okay? So this is the formula that you have to use if you want to do it not with guess and check. Okay? So this would be you plugging in values for L. You plugging in values for L to find the perimeter without doing guess and check.
My 25 or negative 25?
Okay? So if I say L is 1,
Oh, thank you.
right? I plug in 1 here, so 2 times 1 plus 40 divided by 1, so that's 2 plus 40, which is equal to 42. I got this. Okay? If I plug in L equals 2, right? Because L is equal to 2. 2 times 2 is 4, plus 40 divided by 4, so that's 10. So 40 plus 10 is, 40 divided by 2 is 20, sorry, is 24. Okay? So I found this answer.
Yeah, I remember getting that.
Do you guys understand that? Okay. Now, doing a table of value, right? So basically this, what I just did right here, is this, which is W is equal to 40 divided by L. And the perimeter is equal to 2L plus 40 over L. Okay? Again, I was able to do this without using these formulas. So if you're not sure how to do these formulas, you can always go back to the old-fashioned way and then, you know, do it step by step and then draw it and then add. Okay? So, yes.
So the area is
Yeah, you can. I'm not gonna erase it.
it's closed, you know, the area is closed for closed.
In this case, it's closed but with a wall.
So with this side, it's wall.
Yes. So you see that side right here? It's a wall that you're not going to use fence for.
And you already just called accounting, obviously use it for 3 sides.
That's right. The perimeter that I need to use for 3 sides. Okay? Now, something that I just want to mention also is that you're gonna see that the more problem you do of this, you're gonna see that the closest the sides are to each other, the correct the answer. Okay, so every time that you have the length and the width are close to each other, as close as possible to each other, then this is your correct answer. Okay, but anyway, so in this case, we have 2 answers, just so I can finish my question and then you guys can copy. So I have 2 answers. If I do the decimal, then I'll be able to find my more precise answer. But in this case, we're not going to do that. Okay? So I'm going to say here that by 4 by 10, right, would give me minimum perimeter. Or 5 by 5 by 8. Okay?
So always like we look to the minimum or?
In this case, because you're talking about perimeter, you're looking for minimum perimeter. Right? If you're looking at area, it will be maximum.